Hello, my name is Zdeněk Šustr and I work at the Department of Distributed Computing at CESNET. We have traditionally been dealing with interoperability in clouds, but we are also members in INDIGO-DataCloud, where we have been working on virtual networking. We have been primarily focusing on local virtual networks in cloud sites, but we also wanted to take a look at interconnecting these networks across large geographical distances. So to that purpose, we have developed the Indigo virtual router, which is a component that I'm going to introduce to you in this demonstration. Our demonstration will be using resources in 3 sites. One of them is located at our home institute in Brno in Moravia. The other one is an EGI federated cloud site in Pilsen, which is in Western Bohemia. And finally, we will be using resources rented from the Amazon cloud at the Virginia site. We have a local virtual network in each of our sites, and each of those networks has an instance of the Indigo virtual router. The Indigo virtual router is an appliance that is based on open source products, and it is installed in each of the target sites on their own clean Linux distribution so that it is assured that it works properly in the target environment. There are secure connections between each instance of the routers. Out of them, the one that is located in our home institute, is the central node. All the others communicate through it. And also this center node is the only machine in the whole setup that requires a public IP address. All the other machines, be it the compute nodes or the other routers, are run only in private networks on private addresses. We have deployed a Hadoop-based platform across the whole setup so that we have some application to demonstrate the functionality on. And we have a head node in our home institute, but worker nodes are spread across the whole infrastructure in all those 3 sites. So this is a status page for our data nodes, and as we can see, only the local ones are currently available. Hadoop knows that there are supposed to be other nodes, but cannot see them because there is no routing to those other networks. So now let's start up the virtual router in our EGI federated cloud site. I have deployed it earlier to avoid waiting while all the necessary packages install. And the address of the central node and the other configuration details have been supplied already in contextualization. I have, in this case, deployed the node manually, but all the steps that I had to take can be also done programmatically so that the virtual routers can be set up automatically by, say, platform as a service orchestrators or other custom workload management systems. So the second virtual router should now be running, and when I switch back to my Hadoop status page, I should see, thanks to the magic of video editing, that my new nodes are immediately visible. They went green and they are available to the Hadoop platform. So now we already have 2 of our sites online, and let's start up the third one. The process is the same. We are starting the Indigo virtual router instance, and we have configured it in the same way. It's just running on a clean Linux installation that is provided by Amazon for their HVM virtualization. And now we can go back to the Hadoop status page for the final time. And when we reload, and wait a minute, we see that the final 2 nodes are also already available. The cluster is complete and it can run at the full design capacity. And that's basically it. Obviously, there are concerns to be addressed. Firstly, there is reliability, but we have made sure that the topology may be redundant. There may be multiple virtual routers acting as the central node so that there is no single point of failure. Then there is the dynamism of the environment. Some cloud sites may disappear, others may appear, so we need to reconfigure the routers from time to time. This is a little complicated because we are using standard contextualization to configure the nodes, and this can only happen on boot up. So it may take restarting the routers to upload new configuration, but this is the price we pay for using existing solutions wherever possible, and it may be well addressed in the future. And finally, there is the coexistence with native routers provided by different cloud management frameworks like OpenNebula and Amazon. And this is something we want to explore in the future. We could well be using native tools where appropriate and where they are available, and we could be falling back to the Indigo virtual router in other environments on occasions when it's not suitable to use the native solution. And that's really all. This demonstration will be given at the 2017 EGI conference and the Indigo Summit in Catania. So if you are still in time for that, come meet us at the demo booth. Otherwise, thanks for watching and goodbye.